manages. So from this book, there is a problem here that we can solve, and it says for the water channel flow of figure P3 140, H1 is equal to 1.5 meters, H is equal to 4 meters, and V1 is equal to 3 meters per second. So neglecting losses and assuming uniform flow at sections 1 and 2 of this diagram, okay? So this is like a flow channel. So flow at 1 and 2, sections 1 and 2. Find the downstream depth H2 and show that 2 realistic solutions are possible, okay? Yeah, hello everyone, and good day. Welcome to the day 2 of our program, and we're still continuing from where we stopped, and I want to believe that the little we have done yesterday will be an addition to what we have learned previously. So today we are looking at how to create functions, okay? So we're able to solve some problems yesterday during the SymPy. Today we'll be looking at how we can declare a function. And to declare a function, all you need to do, you need to use this word define. So let's say, for example, we want to calculate the distance, okay? The distance, given this formula, we can calculate the distance. So distance is defined as ut plus half at squared. Then we can define the distance as putting all the variables ut and a, and then we say s. Then you have to use this return s. Remember that we have a column here, so you must always use this Python syntax that says you should use def as a function. Then the name of the function is this. You declare the function name as distance. And so when you are calling the function, you call it the way it's called in line 7. So u here, 1 will stand for u, and 0.1 is for t, and a is for acceleration. So when we run this code, it will return the computation of s. So this helps us to do computations without stress and repeat the same computation without having to write over and over again. So all we need to do is just to pick this function, and then we complete our computation, okay? So this is another way also of writing, so that you can always remember what you have written. So you just put the information about the function inside the text, okay? So you can do the description in there. So when you call this function, when you run this time around, and you say distance, okay, dot info or dir, okay, so this is not giving us, it should give us ought to be directory, I guess. Okay, it doesn't have that attributes. So let me try there. Okay, there also is not there. So it should be the doc. Let me see. So why is it not? So distance. Yeah, so when you just type that, it will give you the characteristics, okay? Just type the name of the function, okay? It will give you all that is in it, okay? So it's telling you that u is going to be the information there, initial speed, time elapsed in seconds, acceleration in meters per seconds, okay? So that is the way the information is written. Now, assuming that we have to compute these values, iterates in multiple forms from I is equals to 1 to n, okay? So n can be any value, right? So we want to compute this information and find the summation, okay, of all the computations giving us this. So for example, if you have some of your tabular data sets and you want to find the complete sum, so how does that run? So we first of all assign the number of values that we want and 20 of them. Okay, so you initialize that function with 0, just like we have I is equals to 1 here. That's the initial point. So same way here, you can say the sum of n, if it starts from 0, and I must start with 1. So if I is equals to 1, just like we say I is equals to 1 here. So you say while I is less or equals to n, what you do is that continue to put all these values, which is what is in the bracket here, 2 multiplied by I squared plus I. Okay, 2 multiplied by I squared plus I. Okay, plus. So what this does is that it says I plus equals to 1. So what this does is that it goes round and round and loops over these values, plus 1, plus 1, plus 1, plus 1, and it will do that 20 times, okay, because n is equals to 20. So if this is less than 20 or equals to 20, then it will run that operation and return the total, the sum at the end of the day. So let's do this and see what it gives us. So you can see the sum of the computation of these values between 1 and 20 gives us 5,950. So this also, you can turn it into a function so that you just give the initial value and then the final value, which is n is equals to 20, and then it will always return the information you require. So there is what we call conditionals in Python. So if you want to find whether a matrix is invertible or not, you can use Python to do that. So matrix is basically your number of rows and columns. Okay, so if you look at this, it's in form of a list. So you have a NumPy array of data set given to you as this. So when you run this code, first of all, we just want to see what the matrix A is. Okay, let's just see what the values of matrix A and the shape is, or the length of matrix A, so you can understand what that matrix A looks like. So you can see this is the array of matrix A. Okay, so if you say dot shape, let's see if this matrix, right, so you have a 3 by 3 matrix. So you have 3 rows and 3 columns. Okay, so your matrix is a 3 rows and 3 columns matrix. So if you say length, it will tell you the total length of this matrix. So you can see it's a length of 3. So it has 3 sets of values in a list. So you can see the first one, the second one, and then the third one. Okay, so all of them are values of integers. You can equally have a float. A float is when you have a decimal point inside the data. So now what this is trying to determine is whether this is invertible or not. So you can now define the variable as numpy.len algorithm. Okay, so whenever you put your cursor here, it can tell you what this is, a numpy.len alg. Okay, so it says it's a linear algebra function relying on BLSA and LAP, low-level implementations of standard linear algebra algorithm libraries. Okay, so you can read more about this and see how it works. Okay, so these are all the information about this function. So it's going to determine whether this matrix is invertible or not. So if the determinant is not equal to 0, the matrix should say it is not invertible. Otherwise, it should print the matrix is invertible. Okay, so this is how it goes. So you can see it says matrix is invertible. So you can create any function to check on something. You know, that's what we call it conditional. So if A is greater than B, print B, else print A. Okay, so then if you define that, that gives you what you require. Then the length of the matrix is this. All right, so let's go into some more stuff here. In continuation of this day 2. So now we want to see how we can utilize this Python to solve specific problems. We declare functions, we use for loops and while loops. I've given an example of while loop, when you are looking at conditional statements also. And then look at NumPy, how to do simple plots, and then process a few images, basic images. So from this book, there is a problem here that we can solve. And it says for the water channel flow of figure P3 140, H1 is equal to 1.5 meters, H is equal to 4 meters, and V1 is equal to 3 meters per second. So neglecting losses and assuming uniform flow at sections 1 and 2 of this diagram, okay? So this is like a flow channel. So flow at 1 and 2, sections 1 and 2. Find the downstream depth H2 and show that 2 realistic solutions are possible. Okay, so you have all this, the diagram indicated for you. So you pour water from here and then it flows down to this point. So the first thing is for us to be able to use the Bernoulli equation. So once we understand the Bernoulli equation of flow, then we'll be able to solve this problem. And we already know that this is the equation of Bernoulli. So in order to solve this equation, we use the symbolic Python to be able to attribute all the variable names. So for example, import SymPy as SP. So we define H2, V2, and G as H_2, V_2, and G. So this is what we are going to use in the analysis. For example, if you look at this equation, you only use values of symbols in the equation to associate that, so that when you are inputting the values, it will be easy to do. Okay, so G_val is given as 9.8, H1 is 1.5 in meters, H is equal to 4. In any case, if there is need for any conversion, you can do the conversion also here by either multiplying or dividing by the factor. Okay, so V1 is equals to 3. Okay, so apply Bernoulli's equation, which is the energy equation. We can say equation 1 is equals to SP dot equation. Okay, so you have H plus H1, capital letter H plus H1. So invariably we are looking at this equation. Okay, so this equation, and then we want to return and display the equation and see how the equation looks like. So we run this equation. So when we run this equation, let's see what it gives us. Okay, so you can see it says the equation is 5.5 plus 9 all over 2 of G, okay, is equals to H2 plus V squared 2 all over 2G. Okay, so that is just the, the equation that we have generated there, right? So energy equation is what we have just derived here, we have shown here. All right, so you need to master how equations are written so that you will be able to, make use of them. All right, so